Hi, welcome to part 4 on the Rover P6 engine rebuild. I know Hugh likes all these little video snippets, but there seem to be plenty of you guys watching it, so this is for you guys as well. So here we have Hugh's V8, relatively unremarkable in that it's a V8 Rover engine, 3.5 litre. Slightly unusual in that this is a 9.75 to 1 compression engine. This is actually out of a Rover SD1 Vitesse, so originally it would have been a fuel injected engine. But other than the fact that the compression, it's not particularly remarkable, except that one, you can see here how Rover strengthened the block in comparison with the early ones. If you look at these ribs here in the valley, they're wider and deeper than those on this early P6 engine that we have on the floor down here. See how much shallower they are and lower and narrower compared to there. So that's just, those thicker ribs are just one little example how supposedly the same engine did evolve over the years. Rover improved it and added more material. But oddly enough, this engine is actually the cylinder block, should I say, is actually an example of poor manufacturing. And Hugh, you mentioned this, so you'll be interested in this. He commented one day when he was in here about these machining marks here. He said, well, what are those? I said, well, those are where the lifter bores. Hugh's American, so we're talking American here, lifter bores. If we're talking English, we're talking tappets. Those marks there where they machined to put the tappets in. And the question is, why is the big machining marks this side, or not this side? And the answer is that would be to do with when the block was manufactured. It's a cast block. So it's basically molten aluminium poured into a mould. A bit the same way you make a jelly. You pour the jelly into the mould and it sets. But to make all the internal passages, you have something called a core, which is this strange shape that gives you all the hollow bits. And you assemble this core into the casting box, i.e. jelly mould. But if the bits don't fit together quite right, you can get slight misalignment. And you can get bits of the engine that are cast and made slightly further over than they should be. And the end result of that is that it's no big deal, because when it's all made and it's all machined, the machining operations kind of correct it, which meant that the engine will function perfectly. But what you'd probably find is this probably wouldn't be the best choice of block if you wanted a full out maximum horsepower racing engine, because the cylinder walls are probably thinner in those areas, or the cam journals are offset to one side. So one thing I will do slightly different to normal when we build this engine, when I check the timing of the camshaft, which you will always do on number 1 cylinder, which is this one, I'll also check it on a cylinder on the other bank, because this difference in machining here leads me to possibly think that the engine is cast out of square, and we might find the camshaft further over one way and we get the correct time in this bank and the wrong timing on that bank, in which case we would have to retime the cam to produce an average. But here we are, one nice clean block. Last time you guys would have seen it, I'd have been there with my ball honing it, and absolutely filthy. It's now spent about 4 hours in the hot wash.
The world's biggest dishwasher.
The world's biggest dishwasher, getting cleaned. Hone the cylinder a little, mount off, and then it is ready to have a bath. For this engine, we're porting the heads to what I would call road ported. And by porting, we mean grinding out metal, removing metal to improve the flow of air into and out of the engine. The more air that goes in and out, the more power the engine will make. Now there's degrees of porting, but in reality for the road, all you need is minimal work. You take the sharp edges off, you radius the corners, you take the big lumps out. Making it shiny achieves nothing except uses up a lot of time. With a mild road going cam, extreme amounts of grinding is basically a folly. If the engine doesn't have enough camshaft, it can't make use of it. And whilst a full race head will generate a bit more power than a road ported head, you're talking a couple more horsepower for £2,000 more money. What I've done here is a bit of what I call road porting, some sensible modifications. The engine's already been uprated to an extent because what we're actually fitting to this engine are later 4-litre come 4.6 heads. They came from Rover better in the first place. They had slightly better ports, better valve arrangements. Even if we use stock 4.6 heads, we would have a gain. But it'd be rude not to try and find a little bit more gain. So,
is that your motto?
yeah. So to that extent, we've done a little bit of work on the inlets, not a lot. You can see some grinding. And all we've done here, match the ports to the inlet manifold gasket, or the valley gasket, if you're American. And by doing that, we've removed the step between the engine intake and the head. And if you can imagine, having a step there, it trips the air up just as much as having a step in and out of a building. We've port matched the ports to the gasket. If we look into the standard cylinder head, there's a very sharp square edge there. That's a real sharp angle like that. That, as the air comes in, trips it up. So what we've done is we've reworked it, radius the corners, smoothed it out. So instead of that, we now have that. And air doesn't like turning corners. So that's an inlet, and essentially we've done the same on exhaust ports. The valve throats, the area there, has been opened up a little. Bigger hole, flows more air. There's a limit to how much you can go on the standard size valves, but that's a fair improvement. The other modification I've had to make to this is to make it suitable for the valve springs. Now the cam going in this is a Crow cam, American manufacturer, that the owner's imported from the States, not surprisingly. As with most uprated cams, you need a different set of valve springs. You need stronger springs to control the more aggressive lift of the cam or the more aggressive valve acceleration. You also need springs that can cope with more valve lift. This is a standard spring from the engine, and that's actually a P6 spring. P6s had double springs, but essentially those are standard Rover springs. But we have a bit of a problem because the cam came with valve springs from Crow. These are huge in diameter compared to the standard springs, and they won't sit on either the inner or the outer platform. So that's the other work this head has had done. I've had to machine away the inner step and the outer, so the valve springs can sit flat on their seats. Still to do is to replace the valve guides. So once the valve guides have been knocked out, I'll do a tiny bit more porting work around the valve guide area, a little more cleaning up of the porting, fit the set valve guides, cut the seats, heads are done.
Random question, the full Rover will be going back to the States. How uncommon would this car be in the States?
It's pretty rare. It's pretty rare. I'm not nerdy enough to know the numbers. How essentially the P6s were only imported into America for a few years in the early 70s. So it's a very rare car in America.
Very cool.
The engine isn't quite so rare in America, as we all know, because it's a Buick design, as used by Buick in the 50s, and Rover actually bought the design and manufacturing rights. Along with the rest of the engine, the pistons have had a clean. Ironically, the cleaning starts with an old bent piston ring. They usually snap, but this one bent. And the piston ring comes in that, use the piston ring to scrape any carbon out the ring grooves. You need to remove the carbon for no other reason, if anything else, other than the fact that it takes up space. So if you put new rings on there, you then squash the rings in, they won't go in far enough to go back in the bores. But also the ring grooves need to be clean so the rings can expand properly and the gases find their way around the back of them, which pushes them out and makes them seal. So other than cleaning the ring grooves and then the pistons having a 4-hour shower and the world's biggest dishwasher, the detergent gives them a strange greenish tinge. Lastly, the crankshaft. It's had a bath and it's had a clean and it's had the journals measured and polished. Luckily, despite the worn bearings, they're unworn, so they're still standard size, so the crank hasn't need to be reground or recut, as you'd say in the good old US. The crank is just about ready to go back in. But what we're going to do first is just give it a tickle with some pipe cleaners to make sure the oil ways are clean internally. DIY engine builder tip here. One of the hardest things to do is get an engine properly clean. The outside bits relatively easy, but internal oil ways are much more difficult. Take 2 or 3 pipe cleaners, bunch them together and push them in the oil way. And they will come out the other side. And if you're lucky, they come out clean. You can work them backwards and forwards. They're coming out, they're clean, there's no metal. But you really want to keep running the pipe cleaners through all the various oil white galleries until you're absolutely sure that they're spotless inside. And it's a really good way at home, even if you haven't got compressed air, you can make sure they're clean. There's no debris in them. So even if this crank's clean, but as I keep running the pipe cleaners through, the pipe cleaners are getting dirtier and dirtier. But the important thing is, there's no lumps of grip, there's no lumps of metal. Top tip. So that's it for now, folks. Tune in for the next instalment, by which time we'll should have the pot bend together.